Alright, so today it's day 58. I solved the solution of the lead code problems. We are getting there. We are right now at 22 out of 150. Maybe in the next days I change, like given that now our vacations, I'm not like too invested right now in doing many things, just solving like 2 or 3 problems per day. I think that's enough. But maybe I start again doing some couple of projects. And yeah, let's redo like the binary search lead code problems again. And I mean I have to do them like many times until like I have them ingrained in memory. That's it about lead code. It's just practicing a lot. That's what I've realized. All right, so in binary search, essentially you can think about it as it's like 2 pointers, in my opinion. It's exactly the same. The only difference is now that the update of the pointers, instead of being like 1 step, you can update at each iteration like half of the array, and you take the advantage that the array is sorted. All right, so this construction is essentially the same. You start 1 pointer at the beginning, another at the end. You do the iteration until while the pointers don't match, although you have to consider here that if they match, you are also going to check that case, and you compute like the middle. Let's call it mid, and it's going to be the left plus the right index divided by 2. We use this because we could get like a float number, so we use the floor operation, and then we check. The value is gonna be nums mid. I just add this for make it more cleaner. And then we check like mainly 3 conditions. First one, if the value is the same as target, it means that we find the integer, so we are gonna return mid. Then if it's not, we're gonna check if the value is less than target, because if the value is less than target, it means that we need to. So it's gonna be like this. Let's say this is the thingy. So we search for, right? And we ask ourselves if the target is less than the middle. Let's say that the middle value is 2, right? So if the middle value is 2, we ask ourselves, is 2 less than 4? If that's the case, basically it's saying you that you need to now focus on the right half. And to focus on the right half, your left has to now become your current mid. So now the left is equal to mid, and basically the mid is this one, which is the value that you're checking. So you can say are gonna be all the values to the right. So you can just directly say +1. And then if not, it means the other case, so you're gonna move the right. But the logic is like the same. And if we don't find it, we're gonna return -1. Alright. Now let's do the other problem, search into the matrix. In this problem, I feel as if there are 2 ways of doing it, at least. Basically, you are given now a matrix, but it's ordered from left to right. So from 1 to 8, it's sorted, and then the next row is also sorted, and so on. And it's also sorted from top to bottom, right? So 10 is always greater than 8, 14 is going to be greater than 13, and so on. So what we can do, it's one way, which I try to implement it, is first to use like just the first column and try to find to which row correspond the number that we are searching. So basically we know that the first row goes between 1 and 8, the second between 10 and 13, and the third between 14 and 40. So if we're given 10, we're gonna search like a binary search. So you can like ignore this and think about it like just a single list and finding where this 10 lies. And it could lie to the right of 10, to the left, so between these or between these, and you're gonna get like a row, and then you apply like normal binary search to that row. And that's it. In another way, which I believe probably I should learn it, it's you can treat everything as a flattened list, and you perform a binary search over the flattened list. So let me think about it. Like, I remember that's the intuition, but I don't exactly remember the solution. Yeah. Okay, I got it. So we start again the pointers left and right from 0. Because it's a flattened list, this is gonna be the index 0, and this is gonna be the index, rows times columns. And I mean, we gotta define how many rows there are, and the amount of rows is gonna be like the length of the matrix, right? Because the matrix the dimension is always rows times columns, and the columns are gonna be the length of matrix 0 or 1 or 2 or whatever. So it's gonna be over the first dimension. And I think probably, yeah, we can always assume that it's a 2D array. So we can do this. And then we can say that the right element, which is this one, it's gonna be rows times columns, which is gonna be 12. Well, given that we are beginning, this is the index 0, we're gonna do -1. And we do the same. It's like a standard binary search. While left less or equal than right, we're gonna do the mid, which is gonna be left plus right divided by 2. And then the value, here is what it changes. Now the value is not simply, because normally I would do like matrix mid, right? But now we have an array. So basically here the intuition is like the middle index between 0 and 12, it's gonna be like at half of the rows. I think it's very difficult to explain. But I actually think that you gotta divide by columns, now that I think about it. Because the columns, it's how long is the row, right? So this is length of rows is gonna be like amount of rows 3, amount of columns it's 4. So if you divide like 12, I mean it's 11 by 4. 11 by 4. No, I'm sorry, 11 by 2 first, which is 5, because it's a floor operation. And then 5 divided by 4, no, by 3. No, so it's by rows. I think it's by rows. I think it doesn't matter, probably, actually. Let me think about it. If I have... What happens if I have like a matrix like 3 times 10 and I'm given, I don't know, like... How do I find like the middle value? If it's 3 times 10, it means that there are 30 indices. if you have to give me the middle value as ei comma j in the matrix 3 times 10, what number you would give? I think you're gonna give like 1 comma 5, something like this, like 1,4, 1,5. Yeah. Okay, now it's very clear. Basically, you ask yourselves, how many 15s can I fit if I concatenate? How many rows will I have? And you can have as many rows as the size of the row, which is the amount of columns. Yeah. Because in this case is 4. So if you're given 12, you're gonna say the first 4 corresponds to the first row, and then another 4 correspond to the second. And this is how you map. The columns, and you do floor, right? And then the remainder you can put it in the second index, because it's gonna be rows and columns. So it's gonna be mid divided by columns, which is the amount of columns, which is the size of the row, and it's gonna be mid what it remains when you divide by columns, and you perform like normal binary search, which is gonna be if val equals target, then return true, if val less than target. We gotta move the left pointer, and else we're gonna move the right pointer. And if we do all of it and we didn't find anything, we're gonna return false. Okay, good. That's it for today. Yeah, today problems were quite easy. Let's see how it goes the next days.